As far as the PigBus code itself, pigdevice.h, which is what we link into our devices, this is just the main program. It's got a memory pointer. The main program basically is created by SimH, and it's passed 3 sets of information. The first is the slot ID, which I'm not sure we use for anything, but it passes that in. And then it passes a shared memory address, which it uses for getting and sending information with SimH. And then it passes the file descriptor for an interrupt pipe, which the device uses to send interrupt requests back to SimH, so that when it polls to look for interrupts, it can tell who's requesting an interrupt. It attaches to the shared memory, and then it basically just calls the main loop, which is the thing that start dev declares main loop. And when we hit end dev, we come out of the main loop, we come back here, detach from memory, close standard in and standard out, and we return. So this process exits at that point, and the rest of this is just some helper code for reading and writing registers. As far as SimH changes, there's the usual changes to PDP-11 defs, PDP-11 IO, PDP-11 sys, and then this is our actual device. So in the defs, you can just search for pig. We're basically setting up where this is in the set of priority level 4 devices, so it comes right before the paper tape punch, and I moved the paper tape reader down to the end. Didn't have to do that. And then define int underscore pig, shifting 1 that number of bits, set the interrupt priority level to 4, and I think that's all we have to do with that. IOlib.c, this is where we set up the actual addresses on the UNIBUS, and so the pig sits at 16400, vectors through 140, and this was an old, I believe an A to D converter that wasn't enabled by default, so I stole its vectors and addresses, and that was test code that doesn't get used for anything. And then in PDP-11 sys.c, extern device pigdev, and we put it down here at the bottom of the list of devices, sim devices. And this is all just knowledge from Oscar's BMP 180 tutorial. And then PDP-11 pig.c, this is the main file that defines the PigBus device, and it's repurposed from the paper tape reader. So I've got the original copyright notice and disclaimer from Robert Supnick in here, and then I made, most of this is new code, but I kept some of the old stuff intact, so I threw in my standard disclaimer and licensing terms in here. I don't know if they're valid or not. Basically, this sets up how often SimH is going to poll to see if there's interrupts coming in. This is whether or not we're doing interrupts at all. This is a soft variable we can change to disable polling. This is the longest length for help messages, 100,000 characters. That should be plenty. And then the stuff in the top is mostly boilerplate. The device information block, the unit, the modifier, so this is the stuff we can set and show. And then this is some support code, and everything from here on down is the actual code for the PigBus. So I'm not going to go through this in gory detail, but basically when you do a read, this function gets called, and it says what address you're trying to read, and this is where we can put the value that was read to send back. and this tells you what kind of access, whether you're reading from the console or from code. So if you're reading from the console, we have to do some funny business because it reads multiple locations. But basically, if you're reading from the slot register, I just take my storage slot register and put that in the data register and send that back. If you're reading the CSR, if your slot register is 0, I send back the CSR register for device 0. Otherwise, I say read the device CSR for whatever slot the device is in, put that in data. And same thing for reading data, and that final fourth address is reserved. Writing to a register, pretty much the same idea, except if you're writing to slot 0, I set the slot register based on the low 8 bits of the value you wrote. If you're talking to a device that's in a slot other than 0 and it's not currently running, then I go ahead and start the device, and I pass it the slot number and the device number. So this is the device number, that's the slot number. If you're writing the CSR register, I either save it in CSR 0, or I say write to the device in the slot register, write the CSR register or the data register. And this write dev and read dev, these functions are just exchanging with shared memory. Pig service, this is the routine that's called when the interrupt polling hits in the event queue, and I basically check to see if interrupts are set, and if there's anything coming in the pipeline from any of the devices requesting an interrupt, and so on. And if after all of that there's an interrupt request that should be honored, I just say set int. That's a macro from inside SimH. And then to reset, we just take care of some housekeeping, but we also get reset called when the device first gets loaded into the system. We have a one-time initialization with this, which is handled in init all, which will initialize some variables and do some startup. When we reset, we also flush out the interrupt pipe, so that anything that's been requesting interrupts, those queued up interrupts go away. There's no attaching, so we just print a message if you try to attach. There's no detaching. The help message is big and long, so we've got all the information, the static help information, but then we also go into the PigBus directory and we look at the device list, and for each device in there we look for a help file, and if we find it, then we go ahead and open up that file and read in each line and append it to this big long string that we're defining up here. And when we're done, we call SCP help, and that will take us through the detailed help. There's the description, here's the initialization. The main thing initialization does is check to see if we've ever done any initialization. If we have, we go through and we stop all the running devices. We set all the running flags to 0, and if this is the first time that we're initializing, we create that interrupt pipe that's going to be shared by all of the devices. We make that pipe non-blocking, and then we go ahead, if this is the first time we're doing this, we go ahead and we add to the event queue a request to call the pig service code to let us see if there's anybody requesting interrupts. This shuts down the device by basically clearing all the running flags, closing the pipes to each process, which will cause them to exit their main loop, and then shut down. And then starting a device is a matter of making sure the device is not already running, which it shouldn't be. That would be an internal error if it happened. Saving the slot number, which I don't think we need. Creating a chunk of shared memory. Attaching to it. Marking it for deletion once nobody else is attached to it. Saving it in our pig device structure, the ID and the pointer. setting up a pipe for talking to the device, saving that pipe, and then we go ahead and we make a new process. So we fork a new process, and if this is the if this is the parent, we save the process ID of the child, we mark it as running, and then we send some information to that child. We send the slot number, the shared memory ID, and the file descriptor of the interrupt pipe. If we're the child, we go ahead and we use Duke 2 to change our standard in to come from whatever that pipe was that the parents are using. And then we look in the device list file, looking for a device that matches the slot number or the device number. And if we find it, that will give us the name of the file that executes that device. And then we go ahead and we do an exec and run that program. If something goes wrong, we get here, and that's an internal error, so we say we couldn't execute it. And then again, we just have our boilerplate code for writing to devices, which is just dumping things into shared memory, and also pinging the corresponding device by writing to its pipe and either a C or a D to tell it that the data has been changed. Reading from a device is just reading from shared memory. So that's kind of a quick walkthrough of the PDP-11 pig.c code, which is the part that's compiled into SimH, so that hopefully does not have to get messed with too much, at some point.